Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about normal lines.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, y equals x to the third power minus x squared minus 2, and we want to find the equation of a line normal to this function at 1 comma negative 2. First thing I want to do is find the derivative of our function. So let's call it f prime of x, and it's equal to, using the power rule, 3x squared minus a 2x right there, and really nothing else. Now we want to find the slope of the tangent line at 1 first. F prime of 1, we plug 1 in the x value into our equation of the derivative, and we have 3 times 1 squared minus 2 times 1. From there, 1 squared is 1, so we have a 3 here, minus 2 times, 2. And that equals just a positive 1. Well, if our derivative slope is a positive 1, the normal line slope, we have to do the opposite reciprocal. It's going to be perpendicular. So our slope we're going to use is a negative 1. Okay? So let's keep that in mind. Now at this point, it's just algebra. We need to find the y-intercept here. So we have our slope. We use a formula. Y equals mx plus b. So our y value is a negative 2. Is equal to our slope, negative 1, times our x value, 1, plus b. Solving for b, we have negative 2 equals a negative 1 here, plus b. Add a 1 to both sides, and b equals a negative 1. Lots of negative 1's here. And so we can write this as an equation as y equals our slope, a negative 1, so it's very negative, x minus 1 here. And that is the equation of the line normal to our function at 1 comma negative 2. And again, y equals negative x minus 1 is that function and our final answer. We're given this problem right here. Y equals 1 over x minus 4. And we want to find the equation of the line normal at 5 comma 1. Well, I like to find, first step here is I'm finding the derivative, but I like to rewrite my function. I want to rewrite this to be y equals an x minus 4 to the negative 1 power. Okay? And I do that because I find it easier to find the derivative of this. F prime of x, let's call it, is equal to power rule negative 1 times the inside, x minus 4. Take the exponent, subtract by 1, so we have a negative 2 up here, multiply by the derivative of the inside, which is 1. From there, we need to simplify this. So we have f prime, let's bring it back to a fraction, f prime of x. Negative is just in the numerator, negative 1, over denominator, x minus 4, all squared. Well, we want to find now the slope of the tangent line at 5, and that can help us get the normal line. So we put 5 into our derivative, so we have f prime of 5 here is equal to negative 1 over a 5 minus 4 squared. Well, 5 minus 4 is a 1, so we have negative 1 over 1 squared, which you can see is just a negative 1. Well, that means our slope of the normal line is the opposite reciprocal, so the opposite reciprocal of negative 1 is a positive 1. So our slope that we'll be using is a positive 1 here. Now we need to use algebra. We use our y equals mx plus b form. We have our slope and our coordinate point. Y value 1 equals our slope 1 times the x value 5 plus b. Let's solve for b. Well, 1 times 5 is 5, so we have 1 equals 5 plus b. Subtract a 5 to both sides, and b equals a negative 4. So we have our slope, we have our y-intercept, we have our equation of the function. Y equals our slope 1, which you don't need to write, so we just have x minus f4. And so y equals x minus 4 is the equation of the line normal to our original function at the coordinate point of 5 comma 1, and so is our final answer. We're given this problem right here. Y equals a negative x to the third power plus 15x squared minus 72x plus 110, and we need to find the equation of the line normal to this function at 4 comma negative 2. Well, first thing here is I want to find the derivative of our function. It involves a lot of power rule here. So let's go find f prime of x. Bring down our exponent. We have a negative 3x. Subtract the exponent by 1, squared. Plus 15 times 2 is 30. X, subtract the exponent by 1. leave it there as 1 power. Minus just 72x here, or just 72, sorry. X goes away. And derivative of 110 is, well, nothing. So we have our derivative here. So what we want to do now is find the equation of the tangent line there, and that can help us find the normal line, or so this is the slope of the tangent line. Put a 4 in for x, so we have f prime of 4, and negative 3 times a 4 squared plus 30 times a 4 minus a 72. Negative 3 times 4 squared, or 16, is a negative 48. 30 times 4 is 120, and minus a 72. All of that comes out to be 0. So the slope of the tangent line right here is 0. So if we do the opposite reciprocal of that, it's a 1 over a 0. So what does that really mean? We can't really do that, right? That's not good. Well, the slope of 0 is a horizontal line, which means then the opposite of that, or perpendicular to that, would be a vertical line. And so here we actually have our normal line. Our normal line is a vertical line. And it's at where, well, we just cross our x value right there. So it's at x equals a positive 4. And so our final answer for the equation of normal line of our function at 4, negative 2 is a normal line is a vertical line at x equals 4. We're given this problem right here, y equals 2 over x minus 3, and we're going to find the equation of the line normal to this function at 5, 1. Now I'm going to rewrite my function first. I like to write this as y equals 2 times an x minus 3 in parentheses to the negative 1 power. And I do that because I know I will be finding the derivative, and I like taking the derivative of this better. So f prime of x now, we need to find that. Negative 1 comes down, so we have 2 times the negative 1 here, times the inside, x minus 3, to the negative 1 power minus 1, which is negative 2. Multiply that by the derivative of the inside, positive 1. Let's go simplify this now back out. F prime of x is equal to our numerator, 2 times negative 1 times 1 is a, well, negative 2. That's going to be over our x minus 3. We can bring down to the denominator, but we make the exponent positive 2. So we have our derivative here. We need to find the slope of the tangent line there at 5, 2, and that will help us get the normal line. So we take f prime of 5 here, the x value, and plug it into our equation. Negative 2 over 5 minus 3 squared, right there. Now let's go simplify. Negative 2 over 5 minus 3 is a 2, so we have negative 2 over 2 squared. And what does that come out to be? Well, negative 2 divided by 2 squared is negative 2 over 4, which is a negative 1/2. So if the slope of the tangent line is negative 1/2, the opposite reciprocal will be the slope of the normal line. So we flip it, change the sign, and we have m as a positive 2 here. Okay. Now with that information, we need to find, well, the y-intercept. And this is just algebra here. We use our formula y equals mx plus b. We have our 1, which is our y value, equals our slope, which is 2, times the x value, which is 5, plus b, and let's solve for b. 1 equals 2 times 5, which is 10, plus b here, and subtract 10 to both sides, and b equals a negative 9. So we have a b value of negative 9, m value of 2. We can write this equation, y equals 2x minus 9. And so our equation of the line normal to our function at 5, 2 is y equals 2x minus 9. We're given this problem right here, y equals 3 over x plus 2, and we want to find the equation of the line normal to this function at 4, 1/2. Now I know I'm going to have to find the derivative as part of my steps here, but I like to rewrite my function because I like to take the derivative a different way. Y equals 3 times the denominator, x plus 2, to the negative 1 power. That allows me to, well, when I take the derivative, I just like seeing it this way. So let's go find f prime of x, and that's 3 times this exponent, negative 1, times the inside, x plus 2, raised to subtract the exponent by 1, negative 2 power, times the derivative of the inside, which is 1. From there, let's go simplify. F prime of x here is equal to 3 times negative 1 times 1, which is a negative 3, over, let's bring this back down to the denominator, x plus 2 to the positive 2 power. Now, from here, we want to find the slope of the tangent line, and we can use it to find the slope of the normal line. So we take our function, or derivative, f prime of x, and we're going to put in our x value 4 in for x. 4 here is equal to a negative 3 over 4 plus 2 squared. Simplify this down a little bit. Negative 3 over 4 plus 2 is a 6 squared. Well, we have now negative 3 over 6 squared is a 36, and that simplifies to be a negative 1/12. So if the tangent line has a slope of negative 1/12, our normal line will have a slope of the opposite reciprocal. Flip it, make it put a negative sign on it, which makes it positive, and so we have positive 12 here as a slope of the normal line. With that being said, we need to use our algebra skills to find our b value, or y-intercept. So y equals mx plus b, our y value is at 1/2, our slope is a 12, times the x value is 4, and we plus a b here. 1/2 equals 12 times 4, which is a 48, plus b. We subtract a 48 to both sides, and I did the math for you. B is equal to 1/2 minus 48 is a negative 95 over 2. So we have the b value, we have the m value, we can find the equation of the line. Y equals 12x minus 95 over 2. And so there we have the equation of the line normal to the function at 4, 1/2, and that equation is y equals 12x minus 95 over 2. We're given this problem right here, y equals 2x minus 8 to the 1/3 power, and we want to find the equation of the line normal to this function at 0, negative 2. Now our journey first has us take the derivative of our function. Let's call it f prime of x, and it's equal to, the power rule, 1/3 comes down, and we have 2x minus 8 on the inside here. Now the exponent 1/3, we subtract 1 to it, we have a negative 2/3 here. Multiply that by the derivative of the inside, which is a 2. From here, let's go simplify this. F prime of x is equal to, the numerator is just going to be 1 times a 2, right there. Denominator, we have a 3. And then we have this 2x minus 8 to the negative 2/3 power. The negative can be a positive in the exponent down in the denominator, and the 2/3 power is the same thing as the third root of, on the inside, 2x minus 8, all squared. Okay? So we have now our derivative. F prime of x is equal to 2 over 3 times the third root of 2x minus 8 squared. Let's go find this derivative here. And I think actually I put the squared on the inside, right? Yeah, put a squared on the inside. I mean, it really doesn't matter, actually. Oh, I've already kind of pressed it there. All right, so let's go find f prime of 0. We put 0 in for x, and that's going to give us the slope of the tangent line there. Okay, and now we'll use that to find the slope of the normal line. So we have 2 over, and I love it when it's 0, it makes it easier, 3 times the third root of 2 times 0 minus 8, and then we square all that. Well, we have 2 over 3 times the third root. 2 times 0 is 0, and so we have a minus 8 here, squared. Well, 2 over 3 times the third root. Well, the third root of minus 8 is a negative 2. I'm not taking a third root anymore. Third root of negative 8 is a negative 2, and negative 2 squared is a positive 4. We have 2 over 3 times 4 is 12, which is a 1/6 here. Okay? So we have our slope of our tangent line is a 1/6, so the opposite reciprocal of that will be a slope of a negative positive 6. And that's going to be the slope of the normal line. From there, we need to use what we know about y equals mx plus b to solve, well, the equation of the line. So we have a y value of negative 2. Our slope is a negative 6 multiplied by our x value, which is 0, plus b. Now we're solving for b. Well, 0 times negative 6 is 0, and so b equals a negative 2. Pretty easy. We combine these two informations here, and we have y equals a negative 6x minus 2. And that right there is the equation of the line normal to the function at 0, negative 2. And again, for repetition, y equals negative 6x minus 2 is our final answer. We're given this problem right here. Y equals the natural log of x plus 4, and we want to find the equation of the line normal to this function at negative 3, 0. Well, first thing is I want to go find the derivative of my function. Let's call it f prime of x. And the derivative of natural log of u is u prime over u. Well, derivative of the inside of x plus 4 is just a 1, and we put it over an x plus 4 here. Pretty easy derivative. From there, we want to find the slope of the tangent line, and we use it to find the slope of the normal line. So we take our derivative and we plug in negative 3 in for x. So we have f prime of negative 3 here, and for our x value, 1 over negative 3 plus 4. And what does that come out to be? Well, it's 1 over negative 3 plus 4 is a 1, which is a 1. Well, that's the slope of the tangent line. The slope of the normal line here is the opposite reciprocal of that, which is just a negative 1. All right, so we have our slope here. We need to find our y-intercept. Now it's just algebra. Here's the easy part. Our y value is 0 is equal to our slope, negative 1, times the x value, negative 3, plus b. Solving for b here now, we have 0 equals negative 1 times a negative 3, positive 3 plus b, and so b equals a negative 3. We have our slope, we have our y-intercept, we can get the equation of the line. Y equals our slope, negative 1, just put a negative there, x minus 3, and there we have the equation of the line normal to the function at negative 3, 0 is y equals a negative x minus 3. We're given this problem right here. Y equals the negative sine of 2x, and we want to find the equation of the line normal to this function at negative pi over 2, 0. First thing I want to do is find my derivative. F prime of x here is equal to, well, the negative sign stays out here, and the derivative of sine of u is u prime cosine u. Derivative of the inside of 2x is a 2. Multiply that by the cosine of the inside, which is a 2x. Simplify this out slightly. F prime of x is just a negative 2 cosine of 2x, just to make it look a little neater. Now we want to find the slope of the tangent line, and we can use it to find the slope of the normal line. Negative pi over 2 goes in for x, so f prime of negative pi over 2 is equal to negative 2 cosine of 2 times the negative pi over 2. Well, luckily the 2's cancel here, so we have a f prime of negative pi over 2 is equal to negative 2 cosine of negative pi. Well, cosine of negative pi is a negative 1. So we have negative 2 times a negative 1, which is equal to a positive 2. So our slope of our tangent line here is a positive 2. But what's the slope of the normal line? It's going to be perpendicular. So we're using the opposite reciprocal of 2, and so our slope of the normal line is a negative 1/2. Now it's just algebra. Our equation, y equals mx plus b, is going to be used here, so we use our coordinate point and our slope. Y value 0 is equal to our slope, negative 1/2 times the x value, negative pi over 2, and that's plus a b value. Keep going, is 0 equals, well, negative 1/2 times a negative pi over 2 is a positive pi over 4 plus b. Subtract a pi over 4 to both sides, and b equals a negative pi over 4. We have our slope, we have our y-intercept, we can have an equation of a line. Y equals a negative 1/2 x minus pi over 4. And there we have the equation of the line normal to the function at negative pi over 2, 0. And that equation is y equals negative 1/2 x minus pi over 4. I hope this video was helpful for you. And if it was, please subscribe to this YouTube channel, like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math, When you need help, you use Minute Math.